Hi and welcome to Quick Math. In this segment, we'll be talking about numbers. By all means, do spend time on the tutorial questions as they're specially designed to help you better understand the concept of numbers. For what's coming, look for the word begin with the red background and follow the arrow. The subsequent slides will consist of natural numbers, whole numbers, integers, fractions, rational numbers, irrational numbers, real numbers, and prime numbers. The simplest form of numbers are non-partial numbers. The positive number 1 and above are in the classification of natural numbers. Whole numbers in turn are natural numbers plus the number 0. As for integers, they encompass non-partial numbers that are both positive and negative. Let me now switch gears to tutorial questions. You can so choose to press the pause button now should you need more time to think through the question. Tutorial question 1. Which of the numbers below are natural numbers? The correct answers are the first two on the left. With respect to integers, natural numbers are integers larger than 0. Tutorial question 2. Do press the pause button now if you need more time to think through this question. Which of the numbers below are not whole numbers? As whole numbers are 0 and all positive integers. Numbers that are not whole numbers are negative integers as well as non-integers. Therefore, the correct answer are the three numbers on the right. Tutorial question 3. As usual, press the pause button as required. Which of the numbers below are integers? As integers are non-partial numbers, the only incorrect number is the one on the bottom right. Next, we shall talk about fractions. A fraction consists of a numerator, or the top portion of the fraction, and a denominator, or the bottom portion of a fraction. The numerator represents how many parts, and the denominator represents the whole. Together, they represent how many parts of a whole. For example, 1 over 2 means 1 part out of a total of 2. Likewise, 17 over 20 means 17 parts out of a total of 20. Having spoken about fractions, a rational number is a number that can be expressed as a fraction consisting of a numerator and a denominator with the condition that the numerator and denominator are integers and the denominator being not a 0. When the denominator is 1, every integer serving as the numerator would be a rational number. Hence, the integer is a subset of a rational number. Besides fractions, we have decimals, where digits are being placed to the right of its decimal point. We also have percentages, which would carry its own unique symbol, and we have ratios, represented by a colon in between two numbers. I've grouped these together as each has the means to represent some part of the whole. As previously mentioned for fractions, the numerator 1 represents how many parts, and the denominator 2 represents the whole. In the case of the decimal 0.5, 5 represents how many parts, and 10 represents the whole. For the notation 50%, 50 represents how many parts, and 100 represents the whole. As for the ratio 1 to 1, 1 represents how many parts, and the sum of the two ratios represent the whole. Incidentally, all of the above is equal to 1 over 2. Here's another quick view where each of the four notations are representing a similar number, in this case 17 over 50. We shall now move on to tutorial questions. Hence, press the pause button as required. Question 4 reads as, for the fraction 7 over 17, what do you get when you multiply the denominator with the difference between the numerator and the denominator? With the numerator being 7 and the denominator being 17, your answer should be 170. Tutorial question 5. Do press the pause button as required. Which of the outcome below is not the same as half? Yes, the outcome that is different is 0.5%. Tutorial question 6. Do press the pause button now as required. Which of the numbers below is the odd man out? For this question, the common representation is 65 over 100. Therefore, the odd man out is 42 over 80. Tutorial question 7. Do press the pause button now as required. The area of land is 50 acres and it is split by a ratio of 3 to 7. What is the area of the bigger piece? The key word to this question is the bigger piece, making 7 being how many parts against a total of 3 plus 7, which is 10. By doing the maths, you should arrive at the number 35 acres. Coming back to our final set of definitions. An irrational number is the inverse of a rational number. Therefore, these are numbers that cannot be expressed as a simple fraction. Both rational numbers and irrational numbers make up real numbers. 4 more number definitions. A prime number is a natural number greater than 1 that can only be divided by itself and not any other natural number larger than 1. The inverse of prime numbers are composite numbers. Separately, even numbers are whole numbers divisible by 2, and that includes the number 0. The inverse of even numbers are odd numbers. On this page, the numbers highlighted in yellow are prime numbers for integers between 1 and 100, which I think is worth recognizing. There are 25 such prime numbers, and it's worth noting that even numbers are never prime numbers with the exception of the number 2. Here's the summary of how the definitions roll up. 1, together with prime numbers and composite numbers, form natural numbers. Natural numbers, together with 0, form whole numbers. Whole numbers with negated whole numbers form integers. Integers together with fractions form rational numbers, and rational numbers together with irrational numbers make up real numbers. We've reached our final set of tutorial questions, and do press the pause button as required. Which of the numbers below are rational numbers? It's all of them but the root of 3, as the root of 3 cannot be equated to a fraction with both its numerator and denominator being integers. Tutorial question 9. So do press the pause button now as required. Are root of all prime numbers also irrational numbers? Well, the answer is a simple yes. Tutorial question 10. Do press the pause button now as required. Then, does this automatically mean that the root of all non-prime numbers are rational numbers? Not quite. Please refer to the example where the root of a non-prime number is also an irrational number. That's all for this segment of Quick Math. Thank you for staying till the end of the video. If this had been useful to you, Do look out for other segments with the header Quick Math.